Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle, and it's called take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is x plus y is greater than z by Hanks, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have triangle inequality lines, where all digits are distinct on a red line. Furthermore, any three distinct digits, x, y, and z, on a red line satisfy the triangle inequality. That is, x plus y is greater than z, y plus z is greater than x, and z plus x is greater than y. So, that means if you take any two digits on a triangle inequality line, it cannot be greater, it has to be greater than any other digit that is on that inequality line. I think that's the way I would put it, right? And that's why this puzzle is called x plus y is greater than z, because that's the triangle inequality, or that's the first part of the triangle inequality. But it's basically any three distinct digits on a red line. So that means that for every two digits, so every digit on a triangle inequality line are distinct or unique. And if you take any two of the digits on the inequality line, they will be greater than any other digit, or any digit, period, on, if you sum them together, I should say, then they will be greater than any digit on the triangle inequality line. So that's how triangle inequality lines work. We also have German whisper lines, where adjacent digits on a green line have a difference of at least 5, or as I like to call them, whisper 5 lines, which was a name that a setter came up with, and I thought it was great because you could just, it's very easily extensible. So say we had a whisper 5 line here. If we had a 3 here, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how German whisper lines work. We also have inequality signs, where an inequality sign points to the smaller of the two digits it sits between. So if you have two digits with the inequality line between them, the smaller of them must be the one that's being pointed at. And finally, we have dynamic fog of war, where entering a correct digit clears fog in its cell and may or may not clear fog in other cells. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so as I said, on the triangle inequality lines, if you add any two digits on the line, they must be greater than any digit on the line. So I don't think you can ever have 1 on a line, on a triangle inequality line, right? Because if you have 1 plus another digit, let's just say 6. We have 1 and 6. That means they must be, those two together must be greater than any digit that's on the line. Well, that would mean it's 2 through 5, but then the 1 plus a 2 through 5 has to be greater than the 6, which obviously it can't be. So 1 can never be on a triangle inequality line, which means 1 in box 1 has to be here. Can 2 be in the 5-length inequality line? I think the answer is no. 2, if you have 2 and another digit, 2 plus another digit, like say you had 2 and 8. Hmm. Okay. Where is 9 in this puzzle, I should say? Or in these boxes? 9 in these boxes, if it's on this inequality line, that means all the sums of those digits of the other two digits must be greater than 9. Okay, yeah, what happens if we have 2 here? Well, there's also, okay, 2 and 3 are going to have to be on some inequality line in box 1. If you have 2 and 3 on the 3 length line, then you have 2 and 3, and it must be with 4. Because 2 and 3 is equal to 5. You have to have the other digit be smaller than that, which would be 4. And that works if this is 2, 3, 4, and this is 5 through 9, right? 5 and 6 at minimum add up to 11. Or 5 plus 7 adds up to 12, 5 and 8 add up to 13, etc., etc. Right? So all of those digits are going to be greater than 9, which is fine. If you have them split, how does that work? Okay, you can't have them in this line, both of them here, right? If this is 2 and 3, that would mean 2 and 3 are greater than 5, which would mean the other 3 digits have to be smaller than 5, but obviously that can't work. So what happens if you have like 2 here and 3 here? Well, 4 is going to have to be on one of them. So, okay, say we had 2, so 2, 3, and 4 are interesting. If you have them 2 and 3, so if you have 2, 3 here, then 4 has to be with it. If you don't have 2 and 3 together here, one of them has to be here. So say we had 2 and 4 here, and then this had 3 with it. Well, the problem is with that is 5 and 6 at minimum is not going to be, well, actually it is greater than 3. Okay, let's just say you had 2 and 4 here. If this is 2 and 4, that would be 6, which has to be greater than the other digit there. So it would be 5. So you'd have 2, 4, 5 here. You would have to have 3, 6 here, and 3 and 6 adds up to 9, which 9 is going to be equal to, which doesn't work. So you cannot have 2 and 4 here. What happens if you have 3 and 4? Well, what happens if you have 2 here and 3 and 4 here? Well, 3 and 4 is equal to 7, but all 7, 8, and 9 are not less than that. And at least 2 of them have to be there. So that doesn't work with 2 here and 3 and 4 here. What happens if we have 3 and 4 here? If this is 3 and 4, that means we have 7 as the sum. So we have to have either 5 or 6 here. If we have 2 and 5 here, that's 7, which you're guaranteed to have one digit from 7, 8, or 9 there. And same with 2 and 6. 2 and 6 add up to 8, but we know that this is 5 or 6, which means that 2 and 6 would have 8 or 9 there, guaranteed. Actually, it has to have both 8 and 9 guaranteed, and so then it cannot work. So 2, 3, and 4 can't be there. What happens if 3 is here and 2 and 4 are here? Then you have the same problem. 2 and 4 add up to 6, and you have at least one digit from 6, 7, 8, 9 on that line. So this has to be 2, 3, 4 here. And this must be 5 through 9 here. Okay. These digits, one digit is going to be either high or low, and the other is going to be one of the opposites of it. On this line, you have 5 digits on it. 1 cannot appear there. 2 has the same problem because you have 4 other digits with it. Take the lowest of those 4 digits. Maybe this is the better way of thinking about it. If you have 2 on the 5 length inequality line, there's going to be 4 other digits on it. Take the slowest one of it. That means the other ones are going to be at least 1 greater and at least 2 greater. So you're going to have one digit that fails the inequality thing if you have a 2 there. So that can't work. 3, I think, is the same way, right? If you have 3, you have 4 other digits. One digit is going to be the smallest. So you have one digit that's 1 greater at least, one digit that's 2 greater at least, one digit that's 3 greater at least. So 3 plus the smallest digit is going to equal that 4th digit. So 1, 2, and 3 can never be on a 5-length triangle inequality line. Because you have 5 other digits. You have 4 other digits there, and therefore one's going to be at least 3 greater than the other one. So this can only be 4 through 9 here. We have to have one high digit here, and the rest have to be 1, 2, and 3. So this must be 1, 2, or 3, and this must be a high digit. Well, 4 and 5 are guaranteed to be on this triangle inequality line because they can't be 5 or more away from 1, 2, or 3. So this has to be at least 7 or 8 or 9. And if we have 4 and 5 here, that adds up to 9. So 9 cannot be any of these digits here. It's 4, 5, 6, 7, 8, which forces this to be a 9. Okay, again, 1 cannot be on these triangle inequalities. Also, if you have 4 digits on the line, that means 1 and 2 cannot be on it because you have 3 other digits, and 1 is going to be at least 2 smaller than the other one of the other digits. So this must be a 1-2 pair here, which means we are guaranteed this must be 3 and 4 on this line. 3 and 4 add up to 7. And 3 and 4, that means the other 2 digits must be less than 7, which means it's 5 and 6. So that 3, 4, 5, 6 quadruplet eliminates 3, 4, 5, 6 in the rest of the row. So no 5, 6. This is 7, 8, 9. That eliminates 7, 8, 9 here. This is 5, 6 as a pair here. This digit is next to two unique digits on the Whisper 5 line. So is this one. We can't have 1 here, so 1 has to be one of these 3 digits. 2 can be on the line, but only if it was with 3 and 4. If we don't have 2 here. Okay. If we can't have, say we don't have 2, 3, so 2 is only here if it's 2, 3, 4. If we don't have 2 here, 3 and 4 can't be by can't be on the line, because if you have 3 and 4, that adds up to 7 and would require, again, 3 and 4 can't be by themselves on this line, I should say. If you have 3 and 4, that adds up to 7, and the only digits which are less than that are 2, which we already ruled out, and 5 and 6. So 3 and 4 can't be with them or separately. What about, and the problem is 3 with another higher digit, say it's 3 and 7 or 4 and 7. The problem is that the other higher digits, 7 and 8, would be greater than it, right? We are guaranteed a 1 here. We cannot have 3 lows here. So if we would have to have 2 lows at most, which means one of these has to at least be a low. And if you have a low, you have 2, 3, or 4. You don't have 5 or 6 available. So that means 7, 8, or 9 have to be in one of those cases if this is 2 lows. And if you have 7, 8, and 9 adding with 4, again, like I said, 3 and 4 is not greater than 7, 8, or 9. So that doesn't work there. If we try to have like 4, 7, and 8, 7 and 8 add up. Well, that's fine. Huh. Okay, so that could work. Okay, these are all the same set. Orange will mark these as yellow. This is high. This is high and 5. We cannot have, so it's either 2, 3, and 4 here, which could work, which would make this 1. These would both be low, and this would be 2 or 3. You can't have 2 here if you don't, unless it's with 2, 3, or 4. So either this is 1, which would make this 2 digits from 7, 8, and 9. Or we have a 1, 2 pair here. Actually, does that even work? Say we had 1 and 2, again, then that would be 3 and 4 there. So that doesn't work. Okay. So if we try to have not 2 here, that would make this 3, 4, adding up to 7, which is not greater than any other digit possible to be on this line. So we are guaranteed 1 low digit here. And if we try to have 2 low digits, that just fails. So it must be, so we have 1 low digit here. If we try to have only 2, that fails. If we try to have 3, that works. And that's the only way that it works, because you can't just have one here, right? You can only have at most 2 low digits here. And then that would force 2 here. You can't have 3 low digits here and 1 low digit here. So therefore, you must have 3 low digits here for that to work. So this is 2, 3, 4, which forces this to be 1. These are high, so these are low. These have to be a 7, 8, 9 triplet, because this is 2 or 3 to be next to 2 unique digits on the Whisper 5 line. That means we have a 2, 3, 4 triplet in column 2, which eliminates 2, 3, 4 in the rest of the column. So we have a guaranteed 4 here, and this cannot be 4. This digit's also similar in that sense that this cannot have 1 or 2 on it, right? This has 4 digits on it. If we add a 2, that means there's 3 other digits. One of them's guaranteed to be at least 2 greater than the other one. So 1 and 2 cannot be here, which means we're guaranteed a 3 here and a 9 here, which means the other 2 digits on this line cannot add 3 plus another digit cannot be less than 9, which means this is 3, 7, and 8 with 9. That eliminates 7 and 8 in the rest of the column. That means this can't be 4, 5, and 6. It's 7, 8 as a pair. Three and 7 add up to 10, which is greater than 8 and 9. 3 and 8 is greater than 11, or is equal to 11, and 3 and 9 is equal to 12. And then 7, 8 obviously is 15, so that's fine. So these 2 digits are the same. Does that help? This is 1, so this cannot be 1 here. That means one of these 2 is a 1. You know one of these 3 is a 1. Seven and 8 are a pair here, which eliminates 7 and 8 in the rest of the row. So this can't be 7 or 8. It's 9. That eliminates 9 from the rest of the box. So this is 7, 8 pair, which means this must be 2 to be next to both of them on the Whisper 5 line. So that's 2. This can't be 2, so that's 2 there. That means this can't be 2 here. It's a 1, 3 pair, which eliminates 1 and 3 in the rest of the box. So this can't be 3. That's 2. 1 cannot be, again, as I said, on a triangle inequality line, so this can't be 1. That's 3, which makes that 1. Remaining digits here. So we have 1, 5, 6, 7, 8, and 9 here. Where are 3 and 4? In column 3. Can't be here because of 3, 4 pair in the box. Can't be here because of 2, 3, 4 triplet in the box. So this must be a 3, 4 pair here, which makes this 5, 6 as a pair in the box 7. That means this must have a 5 and a 6 on this inequality line. Again, on a 5-length triangle inequality, you cannot have 1, 2, and 3. We have 5 and 6 here, so this cannot be 5 and 6 here. We have 7, 8, or 9 as the third digit here. This is 1 with 7, 8, or 9. Remaining digits in row 7 are 4, 5, 6, and 9. Obviously, 5 and 6 cannot be here because of 5, 6 in this part. And if we had 4 here, 9 can't be on this line. If we have, because 4, 5 is equal to 9, which is not greater than it. And 9 is, if 9's here, this can't be 9. So either way, 9 cannot be here, which means we have 1 out of 7 or 8 here, which means this can't be 7 or 8 because we have a 5, 6, 7, 8 quadruplet here, which means this is 9. So this cannot be 9 here. This is 4 or 9. You cannot have 1, 2, or 3 here. 3 can't be here. Where is 3 in box 8? It has to be here, which means this can't be 3. That's 4. That's 3. Remaining digits in row 8. We have 4 through 8. Interesting. This can't be 5 or 6 again. If this were 4, that would force this to be 9, and we'd have to have 5 and 4 trying to add up to greater than 9, which is not possible. So this cannot be 4. Therefore, this is 5, 6, 7, 8 with 4 or 9 there. We have 1 out of 7 or 8 here, and 1 out of 4, 5, 6 here. Well, since we know we have 1 out of 7 or 8 here, 3 and 4 necessarily adds up to 7, which is not going to be greater than either 7 or 8. So 4 cannot be ever on this line. 5 could be, as long as, again, this doesn't have... well, we have a 4, 5, 6, 7, 8, 9 quadruplet, or sextuplet here, which makes this 1, 2, 3. 4 eliminates 4 here. This can't be 4, as I said, on the line, because we have a guaranteed 7 or 8 on this line. So therefore, 4 in row 8 has to be here. So that's 4, which eliminates 4 there. This is 1, 2, or 3. Because we have a 7 or 8 here, and only one of them, you cannot have, this has to be one of 5 or 6 here, which eliminates, that means if it's 3, 5 here, or 3, 6 here, which we are guaranteed, those add up to 9 at maximum, which is not going to be greater than 9. So 9 cannot be here. Actually, we have to have then both 5 and 6 here. And since we have both 5 and 6 here, 3 and 5 add up to 8, which is not going to be greater than 8. So this must be 3, 5, 6, 7. This eliminates 5, 6 in the rest of the row because of the 5, 6 pair. And this must be 8. So this is 8, which eliminates 8 in the rest of the line. This 5, 6, 7 eliminates 5, 6, 7 in the rest of the column. So this is 8, this is 7. That's 8, that's 7 there. There's no 7 here. It's 1, 8, 9 as a triplet. This digit is greater than that. Again, we have 5 digits on this triangle inequality line, which means we cannot have 1, 2, or 3 on that line. And one of these is low. And since we can't have 1, 2, 3 there, one of these has to be a 4. Since one of these is a 4, that means this can't be 4. This is 9, which makes that a 4. And therefore, this can't be 4 either. 4 is going to be next to 9 on the Whisper 5 line, so one of these is 9. You can't have 1, 2, or 3 here. Therefore, this must be 4 with a high digit. So we have 4 with 6, 7, or 8. And this is 9 with 1, 2, or 3. 1, 2, or 3 cannot be here. On a 4-digit inequality line, you cannot have 1 or 2. So 1 cannot be here. 1 can't be on the triangle inequality line. So 1 has to be here, which makes this 2, which makes that 1. So this cannot be 1 here. 2 cannot be here, and it can't be on the inequality line, so 2 has to be one of these 2 digits. 1 eliminates 1 here. Remaining digits in column 4. We have 2, 3, 5, 6, 7, and 9. 9 cannot be any of these digits because, and we can't have 2 and 3 here. So this becomes a 5, 6, 7 triplet, which eliminates 5, 6, 7 in the rest of the column. And this can't be 2, so this is 3 and 9 as a pair. This 5, 6, 7 also eliminates 5, 6, 7 in the rest of the box. So this is a 4, 8 pair here. Okay. That means the rest of the box here has to be 1, 2, or 3. 3 and 9 are here. So again, like this, 3 in another digit has to be added up to something greater than 9, which means those must be 7 and 8. So this is 3, 9 with 7, and 8. And this can't be 8 because of the 4, 8 pair in the column. So this is 7, that's 8. This can't be 3 because of 3, 9 pair in the box. Therefore, 3 has to be one of these two, which means this can't be 3. Remaining digits in box 2 are 2, 4, 5, and 6. We're not sure which. This can't be 4 because of 4, 8 pair in the column. This can't be 7 because of 7 in the column. This can't be 3 because of 3, 9 pair in the column. So that's 2. There's no 2 here. Where is 7 in box 8? It has to be here. So that's 7. 4, 8 as a pair. We have a 5, 6, 5, 6 pair in column 5, which eliminates 5, 6 in the rest of the column. So this can't be 5 or 6, it's 2. There's no 2 here then. There's no 2 here. 1 eliminates 1 here. So, if this is 4, this has to be 9, which would make that 8. Otherwise, this is 8, so we cannot have an 8 anywhere here. 3 eliminates 3 here, so where is the 3 remaining in row 1? It has to be here. So that's 3. 7 and 8 eliminates 7 and 8 here, so that's 9. No more 9 in the rest of this inequality line. 9 eliminates 9 here, so it's 3 and 9 there. 3 eliminates 3 here, so it's 4 and 3. Okay, 1 again cannot be on an triangle inequality line, so this cannot be 1 here. This can't be 1 here. Again, 2 cannot be on a 4-length inequality line, because there are guaranteed 3 other digits on it, and one is going to be at least 2 greater than the other one. So this must be 3 here. This can't be 1 here, so this must be 1 here. That leaves this as 5 or 6. We have a well, okay, we don't know. One of these digits must be 4, 5, and 6, and the other one's 7 or 8. Well, since we have 2 digits that are guaranteed to be at least 5 and 6, that means 3 and 5 are here, which adds up to 8, which is not greater than 8. So this cannot be 8 here. It must be 7, which forces this can't not to be 7, so that's 8. This can't be 3 or 8. It's 7. That forces this to be 3. 3 eliminates 3 here, so that's 1. This cannot be 1 or 3 here. It's 2, 9 as a pair. 1 eliminates 1 here and 1 there, so this must be 1 there. 3 eliminates 3 from these two cells, so where's 3 in column 1? It's there. 3, 4 cannot be here because we are guaranteed a 7 on this triangle inequality line, and 3 and 4 add up to 7, which is not greater than 7. So this must be 3, 5, 6, 7, which forces this to be 4. That means this can't be 4 here. Where's the 4 in box 2 then? It has to be here. These are in a 1 to 2 rate, or not 1 to 2 ratio. This has to be high and low because they are on a whisper 5 line, and this cannot be 1, 2, 3, or 4, so this must be high. And it cannot be 6 because 6 can only be next to 1 on a Whisper 5 line. So this can't be 7. It's 8 or 9 here, which is next to 2 or 4 here. Okay. Well, we have a guaranteed 9 in one of the two digits in row 5 or 6. We also have a guaranteed 9 in one of these two digits in rows 5 and 6. That eliminates 9 in the rest of the row, or we could just do an 8-9 pair here, which eliminates 8 and 9 in the rest of the row. So this can't be 8 or 9. It's 2, which makes this 9, which makes that 8, which makes that 9, which makes that 8. And 4 cannot be next to an 8 on a Whisper 5 line because it's 4 apart from it instead of 5. So this must be 2. 2 eliminates 2 here, so it's 4 and 2 there. 8 eliminates 8 here, so this is 4, which makes this an 8. 1 eliminates 1 here, so it's 3 and 1. 7 eliminates 7 here. So this is 5 or 6, and this digit must be greater than that, so that has to be 6 here and 5 there, which makes that 7. 6 eliminates 6 here, so it's 5. No 5 or 7 there, it's 6. This can't be 5 or 6, it's 7. That leaves this digit in row 6 as a 5, so we cannot have 5 there. 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 6, which makes this 5, which makes that 6. This is not high, this is not pink. That leaves this as a 5 and this as a 7. Remaining digit in column 7 is a 9. Remaining digit in row 4 is a 4. Remaining digit in row 5 is a 6. And this digit is greater than that. So we have 6 is greater than 5, which makes this 5, that 6, this 5, and that 6, with this being 5. And this is the final digit as a 6. Interesting. The triangle inequality lines, it's a new rule set that I've seen. It does seem rather restrictive in certain senses, but maybe not all of them, right? We were able to get a whole bunch of different triangle inequalities here, right? So that was kind of interesting there. I don't know. It'd be interesting to see if it can be used in other puzzles. I mean, it can be. It's whether it makes sense to it can be used effectively, I guess, in other puzzles. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.